OpenHouse at openhouseproject.co is trying to be a source that assembles analysis-grade home sales data for research and analysis, as well as to do technology demonstrations on a non-trivial data set. So from my own experience that was sort of the genesis of this, there's a fair amount of data you can get from commercial sites, but it's all aimed at the listings they're featuring, and it's all current state. There's not a good way to do historical trends or any sorts of research of that nature. And it's actually quite difficult to get access to this data, even though it's in the public domain, pending most jurisdictions. There are some rare cases, but at least in most of the United States, this is publicly available data. It just happens to not be well accessible because there's no federated open source for this. So that's what OpenHouse wants to be. I also think it's a great place for people to come and hone some skills. Maybe if you want to learn something like D3, come and find a project, participate, and it's a very public way to get people looking at your work and also find people who are willing to help and train. So that's a little bit about the project. Since Scott wasn't able to make it, he came down with the flu. Feel better, Scott. He's done a lot of the work to date on our on our front-end component. I thought I'd run through what that is, not just our web page I'm showing here, but this web application that is intended to be an easy access point for any visitor to come and learn about and interact with the data. So eventually this will be gallery.openhouseproject.co, and it'll be easier to find. And it's meant to be just a way that anyone who just knows how to use the web, which should be all of us, can go through and explore this data. So we've given 3 ways to explore it. The map, which is probably the most common way, I guess. That's why we've now moved it to the front. Raw data, which makes, it's pretty obvious what this is, just everything in a tabular format, despite there being a few issues here to work out. And then analysis, which is a breakdown of the properties you see available on the map, which are defined by the filters I'll talk about in a minute. So it's this contingency plot style where you have rows and columns of things that are being compared. So of course on the diagonal, price versus price, the nice representation for that is this histogram, which obviously is a pretty, in its current state, not the greatest visualization. No offense to Scott, we kind of planned it this way, that the axis needs work, the tick marks are on a line, just something about this isn't quite right. That's one opportunity for people to come and participate, and I'll show a bit of that as I get into it. But then, of course, that bar plot histogram is great when you're comparing, the whole distribution of these various properties. But when it comes to like square footage versus price, scatter plots seem more appropriate. So this, again, not the perfect final version here. We should do something with the alpha on this and the axis as well, but starting point and the data is all there. So that's the 3 areas of sort of our primary interaction in this Canonical data exploration tool. Of course, people should feel free to spin up their own projects, to come to the central project, if you will, and propose ideas and ways to improve upon this. But this is what we're hoping to round out in the near future and kind of have like a good release candidate. We recently added these sliders that help you kind of select, all right, I don't care about bedrooms, or I want more bedrooms. And at present, you'll have to search for that to rerun. We could do that as sort of an async, but there's a lot of questions around how often we should bombard the API with requests. So that's actually a good discussion point, probably out of scope for this meeting, but something we would love some expertise on if people have insights on how to better do that. Similarly, we wanted this to be a way that anyone could access this data, but someone with some analytical skills this could be their gateway and launch a little bit deeper. So the assumption is that most people know what curl is. So as you update these things, notice I'm going to change the price here, it in real time updates a curl request that would get you the properties described by all these features. And we have this copy to clipboard option that works just like on GitHub when you clone a repo. So now anyone could go run that curl request at their terminal and get back the exact response from the API. Maybe in the future we'll add some buttons that could, like, I don't know, launch a Jupyter notebook somewhere and have the Python code, or connect to RStudio or something like that. Cool ways we could improve that just to make the barrier to entry really low. Another interesting feature I'll point out while we're here, the map, let me zoom in. As I pan around and look at different places, down here the mean and median of the price, the number of beds, the number of baths, and square footage is updated to match the viewport of this map. So kind of a cool feature. It's, I think, less impressive in the current state because here we're showing a really wide boundary of the country, and we're not focusing in on the exact area you're seeing. So there are 500 data points shown here, because that's what we call and initially asked the API for, and it gets, I think, pending these filters, a pretty sort of general sampling of them. I don't think it's a random sample. I believe it's by their order in the database, but let's maybe go down to Los Angeles, where I know there's a lot of listings, but aren't in that first 500. At present, I pop up this research this area, yes or no. So if I hit yes, what should happen is we call back to the API, cross your fingers, up, no listings there. So maybe that's a bug, or I'm not exactly sure what's going on. But ideally, that should then search by the exact boundaries of the map, so you'd bring back a refined search. I think in the near future, we're going to switch that over where asynchronously, as you move this, it starts calling the API and refreshing. We only ask for the first 500 because if you waited for, in this zoomed out state, technically this request, since at the moment we only have United States listings, at least as far as I know, this would return back the entire database if you just waited long enough or put in a big enough limit. So we definitely want to ask for some small number. 500 seems to be a good choice. And then maybe ask for the next 500 and next and so on and so forth to fill this in. There's also interesting work I think we're about to kick off on how we cache these locally. So technically, if I adjust this and I search again, as soon as the search comes back, all these markers are going to be erased, all that data is thrown out, and the new data is rendered. So, and then if I change it back, even though the local browser has already seen some of those listings, they're not cached. So there's an opportunity to grow that, make it more responsive and quicker, but also some open questions because we don't want to fill up the local cache with infinite records. So interesting problems to be solved there that we can definitely use feedback and insight on from people. Maybe I should talk next about some of the general structure of the code. And I think I've looked over most of Scott's changes that he put in recently, but let's go to GitHub and just run through. So at the moment, what you see here, which is quickly becoming our kind of primary visualization, was sort of conceived as this, I guess, side project, but it really should be top tier thing. We should probably promote it. But at the moment, it's in contingency plots, sort of thought of as like a one separate feature. So index is the page you see that we were on. The HTML content is fairly light, just divs that have all of the user interface stuff, some controls for error boxes, the tabs. What are we looking at? 168 lines of code. So lightweight, which is good. Most things then are, the style sheet is pretty well specified, even though I think that could be reformatted a bit to be a bit more accessible. It's not particularly organized at the moment. It's just kind of evolved naturally, so some room for improvement. And then scripts, we have this monolithic code.js, which should probably be broken out at some point. Currently, it's using core JavaScript and jQuery. Would be great to add in or migrate some of this to Reveal. Scott said he was trying to do some of that and could use some help. I can't remember exactly what his issue was. But let me run through some of this now that we've got these comments in here, just give people a general sense of the state of this. So there's we're using that, leveraging HTML5 local storage to cache a state variable, which is just a dictionary of kind of the kitchen sink of every variable we might want to have. So the idea would be that if I, let's say, zoom in here, it should now save those settings. So if I refresh, the local state just pulls back. Oh, it didn't work. What it should have done is save the exact viewport and everything about it, including my settings, which looks like those did get captured. So that makes it kind of more contiguous for the user. Would also be good to center the map initially around a person's local area, which is more than likely what they're probably after. Let's see. Here is the actual call to the API. So it's just a jQuery AJAX call. Grabs the data and then does rendering the table, the map, and the plots, which are those three separate tabs. Plots is what's now called analysis. And then mostly I think we've got helper functions here that control that manage the button hits and the statistics that are computed in this box that we're looking at over here. So this, even though it's not that long, what are we looking at? About 500 lines. We've made some recent improvements that make it a little bit more readable through comments, but I think it could still benefit from some structuring from someone who's pretty, in the weeds on JavaScript applications, as well as if, I'm sorry, I said Reveal earlier. React is the framework we probably want to migrate to. We had a lot of people look at getting involved and said, hey, this is the code base specifically on the front end is too broad and I can't really get into it. I've got an afternoon I'd love to share with the project, but was having trouble kind of getting started basically. So one idea we came up with was to put together these very simple short projects, I guess is what you think of them as. So for example, the scatter plot is the one I'll show here. So under analysis, this is the scatter plot we talked about earlier. Clearly, Axes could use some work, you know, play around with alpha channel, maybe even embed, you know, a linear fit or something like that, put some summary statistics. Lots of room for improvement here to make the data more accessible and interesting. But if you don't want to get involved in the monolithic code base, scatterplot.html is a very short 35 lines of code that doesn't do a whole lot. Just says, here's a nonsensical data structure, and pass it to this scatterplot function, which renders that data into this container in this width and height. And that, so this self-contained HTML file just needs this scatterplot.js file, which we should go look at here, which is just some basic JavaScript and some D3 code. Again, only 65 lines of code. I'm sure that'll grow as we make it fancier and more interesting, but seems like that could be a great way for someone to get involved, edit probably just this file. It would be self-contained, and send us a pull request. And since the actual, you know, main gallery site is using that same scatterplot.js file, any pull requests we get once merged would show up right here, and we benefit from those changes. So there's a lot of smaller tasks. Oh, and also thanks to Elliot's recommendation, I discovered Waffle, which is this really great site that integrates extremely well with GitHub issues. So we're probably going to move away from Trello and just use these. They attach to each of the repos we have. So the repo I've been focused on here is just Home Data Gallery, but we've got a bunch of others under the Data Skeptic repo, the API, the one that we'll talk about in a bit, and a few others like API Connector that helps people get started if they want to push to the app, if they've got data and they want to do some crawling. So the way I think this can organize, totally open to suggestions, but I'll leave the backlog for tasks that are ready to go that can be assigned, that people can kind of volunteer for. So for example, improve the scatterplot visualization is the one I was talking about. Here's the relevant link to the basic file. And some comments on what could be improved. So obviously the CSS could make that more attractive. Line width needs some help. The tick frequency, min and max are not always there. Oh, too many ticks. I guess tick should really be dots. Something about this could definitely be improved. So it would be great if someone jumped in, maybe commented and volunteered, or if you're a member of the project, I guess you could assign. I'm happy to add people if they want to get more involved. And that would be a cool way to have a bite-sized piece of work you could do. There's, of course, some bigger tasks as well. The most pressing needs I see are those two things I'd mentioned. One is around how we cache the data locally for these listings, and how we intelligently re-request to the API without essentially sending denial of service requests. So the problem we could have is, the naive way to do this is to say on any change, make a call to the API. But if I just move this map, I'm firing a bunch of change requests through the OpenStreetMap API. I wouldn't want for every little drag the API to be called and get 500 calls that are probably largely redundant, and also maybe the data will be thrown out. So something smarter has to be put in place there, both in terms of how we call the API, how we asynchronously get new requests when more than 500 are available, and then how we do some local caching. There's been some good discussion in one of the channels between Scott and Joy about, I guess, using KD trees locally to do that, and there's a JavaScript library that seems to be ready to go to help with that. So that's just a quick overview, I guess, of the front-end visualization component and where some opportunities to work on it are. Well, I'll say, since we're going to put this on YouTube later, anybody's looking to reach out, you can always email me, kyle@dataskeptic.com. Also, definitely join our Slack channel. Unfortunately, Slack doesn't let us auto sign up, so you have to email me and ask to join. Also, head over to openhouseproject.co. We'll keep this updated with best ways to get involved and get on Slack. I need to add something along those lines here. But yeah, maybe a good time to turn it over to the awesome work done so far on the API and where the frontiers of that lie.
As Carl mentioned, a lot of this is backed by our API. It's a REST API written in Django using Django REST framework. For those that are familiar, currently there are 2 copies of the API sitting on Heroku. There's a development one, which sits at home sales data API-dev.herokuapp.com, and there's also the, we'll call it production version, which sits at the same URL but without the dev part in it. I believe we can also get to them from api.openhouseproject.co. So if you want to access them that way, you can. One of the good things about Django REST framework, and I'll talk through the code in a little bit, is that it provides out of the box these really good web views into a number of the API endpoints. I suppose the most interesting one to look at and where the most work has gone on is in this property endpoint. So any listing that gets uploaded ends up in this property endpoint. I think I just requested 500 items, so it may be a little bit slow. So you can see here what we get back, from the API is a number of these properties, which stores things about their location, so their address, when it was uploaded, and various pieces of information about the property itself, such as its price, number of bedrooms, bathrooms, car spaces, etc. I suppose one thing that we need to look at is which of these features are the most important and which new features might want to be added. Mm-hmm. There is some flexibility in doing that with this features array, which is probably not something necessarily worth getting into, but it allows you to add basically key value features to any property to make it a little bit more flexible to adding new information. But at the moment, you can request this API with a number of different filters. If you're coming in from the web, you can hit this filter button and you can look at various filters on the price and car spaces and things like this, which is mimicked in that gallery application that you saw earlier. Under the hood, I suppose, once we push new data up to this API, it goes through Google's geocoding service, and it takes a address like this. So this is the address that was supplied somewhere here in California, and it geocodes that into something that is more machine readable, which has been helpful, especially with these latitude and longitude values. So from, I suppose, what needs to be done on the API side, there is certainly always more data that could be added, but there are a number of different filtering options and processing options I think would be interesting to see. Right now, we can't filter on any of these address properties, which is something that's been requested and that will be added soon enough. But things like that are certainly open for contribution. I think there's a number of issues on the GitHub repository, which may be a little bit out of date at the moment. I'm not too sure. But we've got some tags here for helped wanted and also easy. So anyone that's got any sort of Python skills whatsoever should definitely be able to jump in and maybe take a look at one of these tagged issues and see if you can create a pull request. But yeah, still very much open to development. A lot of the stuff is still in early days, so I'd appreciate anybody that's looking to help out. Happy to walk anyone through the specifics of the code if they need some help getting familiar with it. But otherwise, I suppose that's where we're at the moment. Was there anything in particular, Carl, that you wanted me to touch on?
No, I think that's a good run through. Maybe just a quick glance at anything that, so people, if they want to get involved, they should probably go learn about Django. That'll certainly help. Anything unique that they should know that they wouldn't get covered in a Django tutorial, maybe?
I suppose the only other one is just Django REST framework, which is the framework that we're primarily using for this project. So that's another good one to read up on. It also has a very good tutorial. So if you just head over to Django REST frameworks, read the docs page, you can follow through with that. But I guess those would be the main two things to start contributing.
Hey, Kyle, can you also touch upon the database side and perhaps anything to do with scraping that you're looking to get help with?
Oh, sure. So the database right now is in Postgres. So I have some questions in my mind about how exactly that will scale. I think it will scale quite well. Postgres has a lot of GIS functionality built in. It's also what, at least as of a few years ago, I don't know if this is still the same, but it had been what was backing the OpenStreetMap. So whatever the scale and scope and future of OpenHouse, it's safe to say that OpenStreetMap will always have more data than we will. So if it's good enough for them, it seems like it ought to be good enough for us. That's on Heroku and has backups, and that seems to be working quite well so far. No issues. There is the scraping side, which is going to be something I'm going to put a lot more pressure on as we beef up our tools and and making that as easy as possible. So what I've found in talking to people is that there's a lot of enthusiasm and success for finding good data sources and scraping them, using requests or Scrapey and then running it through Beautiful Soup and getting the data out. The API is actually really well done for uploading, but there are a couple of hurdles to get that going. So just in terms of like making sure it's formatted and geocoded and whatnot. So one thing is we've built out, actually maybe if I take the screen back, I can show a few more places on our GitHub pages. See if I can share my screen.
Kyle, I'll make you the presenter. Hang on.
Cool.
Okay, now you should be able to share.
One second. Share my screen. Okay, you guys got me?
Yep.
So API connector, this is also, early stages. I eventually was imagining a day when we have R and Java and who knows, Ruby and Scala, Python, anything, other languages that are set up pre-connectors that make it really easy to push data. Python seemed to be the canonical choice, so that's the first one we worked on. And this, we're actually kind of figuring out what's the best method here. Should there be a centralized place where people who build crawlers, like someone built it on forsaleowner.com, is exactly a script that calls that site and has the Beautiful Soup code to parse it and attempts to call the API. So this worked great for a while, and it uses this pusher class, but there's a lot of nuances to both crawling and to pushing to the API. For example, if you just use the geocoding that we built into this pusher class, it's going to, I think it's Google's geocoder, and it taps out at about 1,500 requests per day, and then that script would fail out. So I built this background uploader. I don't think this is totally production worthy yet, but we're using it in a couple of spots. It's meant to make things easier, although there's definitely room for improvement here. And it handles a lot of those corner cases quite well, and is meant to be a command line type application. So if you can get your data scraped and parsed, which people seem to be pretty good at, and you can get it into this CSV or a tab separated file with this canonical header that we provide that has these basic features, which, mind you, doesn't account for all the other features that the API supports, or the, as Elliot was showing, that features area where you could upload extra data you might have, like if it has a swimming pool or something. So this is a little limiting, but it's a starting point to help us get some data in the system and evolve it in time. If you can provide the CSV with that exact header format, then using this, you just tell it where that tab-separated file is, optionally where your properties file is, otherwise it assumes it's openhouse.config. And there's a sample here of just take the username and password that you're issued when you sign up for an API token. This base URL we can probably update to the production or the dev instance. And then some basic controls here on how you want to operate. And the defaults in this file are meant to be probably the preferred version. background uploader will just run in the background and however long it takes to upload stuff, because as you do these singly, even though they're quick, you know, if you have 10,000 of them, that adds up in time. Just let this run, it'll upload them. And it handles cases like when you hit your geocoding limit, let me find that. It tries to manage failures in a smart way and retry, and at a certain point, depending on how you have it configured, the default setting is fail-safe, which means if it gets to the point where you seem to have exhausted your free credits for the day, then it just uploads the listing anyway without geocoding it, and then relies on the server to provide that as a service. So then in the back end, the API will geocode it when the lat and long aren't provided. We'd prefer people provide them because then we've sort of distributed the load of across the geocoding services. Otherwise, we end up paying for it. So far, it hasn't been very expensive. It's a nominal cost I'm happy to cover. Maybe we'll address that if it ever becomes out of control. And then it handles a couple of failure conditions. I actually have some improvements I want to make to this based on some feedback I got from Raj that I talked to this morning. He's been doing some crawls, and he's in I think, Bangalore, so his time schedule is not all that, doesn't suit our usual meeting time. But he noticed that the background uploader is kind of quiet about certain failures. So the API is sending back 500s, probably because something's wrong with the request and he wasn't seeing it. So the other consideration, and I was going to bring this up in the larger meeting, is maybe it makes sense for us to have a canonical crawling system. So people are contributing. Obviously, they can call the API, or they can contribute their parsing scripts, and maybe we run them for them. So there's pros and cons to that, but it's been a bit of a barrier to entry to get data and upload it. I think some of that is the fact that it can be hard to find these data sources, but then there's a lot of things to learn specific to the project. I think things are really well designed so far. It's just you have to learn the nuances. So videos like this one, I hope, will make it a little more accessible, and then maybe I'll even do a screencast where I go through very step-by-step. Here's how you get this data, here's how you call this function, everything gets done here. But for this meeting, I think that might be a little bit too into the weeds. But we provide the background uploader, a couple of other crawling details and some recommendations here, and we'll keep evolving this as people find different data sources. At present, I guess our hope is that people find the data that's important to them and they help contribute it or share where they found it so that other people can team up on that. I may get a bit more aggressive on finding specific sources and asking people to do specific ones. Some of those I've tried haven't come to fruition yet, but I think some of that is tearing down the barrier to entry on just getting it really easy and frictionless for people to come in and find data, parse it, and upload it.
Okay, cool. Is there anything else, Kyle or Elliot, you wanted to say for the recording before we stop?
Nothing on mine. Just thanks to everybody for participating, those here today and those who have contributed in other ways, and you as well, Samir, for setting this up. I think this is going to help people get a better, easy tutorial into the program.